Now just say that all again. Back to the function completely using synthetic division on your calculator. You will need your calculator or the ability to look at a graph and know exactly how it looks. So the process is to first figure out your possible rational roots. So that's your P's and your Q's. Remember, P's go into the constants. What numbers go into negative 90? I'll stick get you started. Plus or minus 1, 2, 5, 9. Oh, we forgot 6. We forgot 6. 6, 9, 10. So there's 90 right here. 9 times 10. 6 times what? 15. 5 times? 3 times? 2 times? I got the last one. 90. Q are all the numbers that go into the leading coefficient. What goes into the leading coefficient? 1 and 3, plus or minus. So P over Q, look at that. Blue and red make purple. You're going to take your P list, divided by each term of the Q list. Well, you always get back to the P list, because you'll always be dividing at least by 1. And now we're going to add any additional numbers after we divide by 3 and we get a new number that's not on this list. So 1 divided by 3 makes 1/3. 2 divided by 3, 2/3. 3 divided by 3 is 1. That's already on the list. What else can we add? 5/3. 1 more. 10/3. And then notice everything else is a multiple of 3. So we don't need to add it. So again, 100 years ago, you would have to check all of these numbers, positive or negative, using synthetic division or plugging it into the function. Way too much fun. Yes. Sure. So Q are the numbers that go into 3. 3 is prime, so just 1 and 3. Okay. So now what we're going to do is go into your calculator and go into your y equals, type that function. Oh. And as stated, as far as the window size is concerned, you technically should include all the values that are possible, negative 90 to positive 90. But in practice, if you just do a standard size window from negative 10 to 10, or just do zoom standard, you should encompass pretty much all of them. I'm going to make this a little bit bigger and take a screenshot. Nope, you're not the right marker. There you are. Boop. Boop. So looking at this picture here, notice we have cross, cross, touch. If you did cross, cross, touch, what's the minimal degree you could possibly have for a function? 4, because this is odd, this must be even. The smallest odd degree is 1. The smallest even degree, well, greater than 1 would be 2. So 1 plus 1 plus 2 is 4. So looking at this picture, are all of our roots real? Yeah, because they're all represented. Because our degree is 4, we have the sum of multiplicities would be 4. Okay, notice this one appears to be What does this appear to be? 1, 2, 3, 4, -5? Question mark. This appears to be a fraction? Question mark. This appears to touch at 3? Question mark. Here's the thing. Don't use fractions if you can. Avoid fractions. They cause issues. We'll talk about those issues when we're all done. Instead, you have a couple options. You can do your -5. Or, since 3 touches, or it touches at 3, you can try 3 an even number of times, in this case twice. Either way. So that everyone's on the same page, let's do 3 twice. So if you would, start with your 4th degree polynomial. Use 3 twice. That should get you down to a quadratic using synthetic division. Oh my gosh, these numbers are so huge. Why? Why? So the synthetic division step, I know what to do, but I'm not sure how to describe it. That's right so far. So that's what? Negative. I got it. 1, 50, 47. Yay. Bam. So 3 worked once. Since it touches, it must work again. That's the thought process. So far, this factors as 3 worked twice, so that means it will be x minus 3 quantity squared times our something, which would be 3x squared plus 13x minus 10. That's what we have so far. So then to finish this off, how does 3x squared plus 13x minus 10 factor? One more time. 3x minus 2 times x minus 5. Let me check. Oh. Yep, so positive 15 minus 13 would be, minus 2 would be 13. Yeah. So x minus 3 quantity squared times 3x minus 2 times x plus 5 would be the full factorization. So there we can see the -5 would have worked as well. And what fraction would have worked? 2/3. Now here's the deal. If you had figured out it was 2/3 and you factored it using the 2/3, well, if 2/3 is a root, then x minus 2/3 is the factor, because if c is a root, x minus c is the factor. The problem is, if you wrote your final answer like this, it's not correct. Why is this bad? This would be right if I changed one thing, or if I added one thing, I should say. Put a 3. Now this is fine. So the reason I want you to avoid fractions is because students forget that when it all oils out, the leading term should not change. Now with this 3 here, you've kept the 3x to the 4th. This one here? From here to here? Yes. 3x squared. Is that okay? So P over Q's, look at the graph. Based on the graph, pick your P over Q for the synthetic division. Get it down to a quadratic if you can. If you can't, that means it's in the wrong book. All these should be rigged to factor completely.